me yet. There you are. Now you can hear me. That's probably a lot better. My first time on YouTube. If you hadn't guessed already. So, we got to turn the mic on. I mean, God. Streaming. Let's try YouTube streaming. It's in now. So there's that. Wonderful. So I'll just close my own stream window. So what am I working on? Well, the basic version is I'm making a simple game in Rust and Godot. How do I show this off? I've got some pics that I can find. Pictures. Some GIFs. So it's this little kind of factory game set on a spaceship. Now, just it's like a standalone ship thing. So at the moment I'm mucking around with networking stuff. Let's just see what I've got here. My work in progress to do with packet mapping. I'll just pop this in. I should have a sound meter somewhere so I can see myself talking it. That way I know it's working. OBS Studio. Yes, so this is a sound meter here. Let me just pop it down. I can see it here. Great. And chat, live chat. There's a live chat window on the side of this. That's good. Chat to me. Wonderful. Over here. So yeah, I haven't been streaming much since the advent of the pandemic. It was all a bit dramatic. I had a bit of a break from my game development. I had a bit of a break from streaming. It just got a bit stressful. So I'm back now. Hopefully it's something I can keep up. I just thought it'd be fun to catch up with everybody and do a bit of streaming. Let's see. I'm just going to whip this. So I go whip, and then I write in what I've changed. This is stuff to track what data has been sent in packets. So I wonder if I need to... Hey Travis, nice to see you. Oh Nesh, I didn't see you there earlier. Hi Nesh, thanks for dropping by the YouTube. So I was going to... Well, let's have a look at what I'm currently up to with that. So we'll start by going through what I'm currently working on, and then, which is all very boring. It's all very code. File settings. I don't need to use the settings anymore. I just need to. We've got control mouse wheel for zoom. So thanks for joining. Let me make this a bit bigger. Make this a bit bigger. So the main thing I'll be working on is packet tracking. There was a rate page on this that I found at one point or another. See if I can find it again real quick. Quake package. I don't really want to show you all my like starting up. Quake package. Resending protocol. Yeah, I'm not sure if I can find the one I was thinking of real quick. But the basic idea is that if you are running a networking game, you want the server has an idea of what the world is, which is authoritative. So like the server wants to tell the clients exactly what's going on, so the clients can just show it on their screen, and the server's the boss. So it sends out on a very frequent basis, like at the server tick rate, updates telling all the clients exactly what's going on. Say, for instance, 60 times a second is what I settled on for my game so far. The Recall Singularity, Space Game in Space. In fact, there's a Twitter feed. Well, you'll figure out how to get to the videos about it. There's even a YouTube video on it right on my channel. Man, I need to organize my channel. When the server is deciding what to send, it's constantly streaming out information about various entities. If you tell a client about an entity and the entity doesn't change again, it's kind of assumed you don't need to mention it a second time. You can just trust that the client will have picked up that information and be processing it. So the server's got to remember what the client knows and what was sent in the past. Well, there's a wrinkle in that plan, and that is that the client may not receive every message. Now, we don't want to use reliable messaging because that causes all sorts of issues. If we're using TCP on the internet, then the protocol will automatically retry if a message fails. But the problem is it causes delays because TCP is also trying to keep the packets in order. And by the time the client gets some information, it may no longer be relevant. So we have a process where each tick we decide what's relevant, and we try and figure out what the client knows or probably knows, and based on that we send the next set of data. And so we're trying to track for each entity. There's a couple of things we're interested in. So in this packet tracking class, I'm representing the idea that there are various ticks that we're sending information out. This structure is what's known as a struct of arrays. So you've got a whole bunch of arrays, and then at index 0, all the data lines up and represents the same moment in time or the same thing. So when I, down here, when I create a packet, you'll see I add to the tick array, the live array, the int sent array, the act array, all at the same time. So I added these arrays. So essentially we're tracking for each packet we send what tick it represents in time from when the server started, a map of which entities were live, a map of which ones we sent. So we're only going to send a subset each time. And this bitmap only holds only holds 256 bits. So as you see on this other side, it's actually a so-called bit mask where we set a bit true when it's relevant. So there's two halves here. There's lots of tests. We track here which packets act, and then we're trying to track which entities act. So I've got a bunch of tests for this, and it's probably better I just jump right in and you guys just watch me struggle to code as opposed to trying to explain every little thing. The ultimate goal is we need to figure out what entities are going to send this tick, and if possible, if we know we sent them recently, we can make a difference as opposed to all the data. Hopefully the tea drinking sounds aren't too graphic. Okay. Does it catch breathing? I think I tuned this pretty well. It's a new microphone. Valid snapshots. So here's a test where we create one of these packet tracking entities, a default one, and ignore the from square, but imagine we're just sitting. Probably should change the name of this routine from square. This is because it used to be a chess thing, and this used to represent positions in a 16 by 16 chessboard. Let's change this variable name. Trying to figure out a good name. Maybe just bit. Instead of square, I might just everywhere it says square in this file. Going to replace in path for square. We call this index because that again was a chess thing. So match case words. It's probably going to be fine. Place all. Place. Great. Some clearer names from position. Yeah. So it's a bit clearer. So we create a packet here for tick 0 that says that only one particular entity is live. So the other thing you need to know is that just imagine there's a limit of 256 entities that a client can know about. There's a mapping between a much larger array of bunch of entities that exist in the sector and which ones the client knows about, but I won't bother explaining that right this second. So during this packet, that particular entity was live, 3, and we sent entity 2, which doesn't make sense. Yeah. I think I was changing this last time I looked at it. Or was the other live one? Or have I lost work? Oh no, it was this one. This is the one I was last working on. Tick entity act. So it's saying that entities 2 and 4 are live, and we send in tick 3, 4, 5, 6, we send 2, then 4, then 2, then 4 again. Then down here we try and track what the client knows based on what the server knows the client knows. Anyway, that was the last thing I worked on. Let's see if the test passes. We'll run all the tests. So my game uses Godot and Rust, but hi Nish. Yes, so I have tea, water, it's licorice tea, as asked by Nish still, and water, just water, and I often get a few raised eyebrows in workplaces that don't know me yet when I walk into meetings with 3 cups of coffee, tea, and water, and then during the long meeting I can just choose which one I want at every given moment. I'm a guy who likes options, so I created a lot of compile issues. In my tests, I was trying to create entities. In fact, that was a problem I wanted to try and solve. So we're going to switch from the packet mapping across to specs. I think you're going to have to just constantly see. There's nothing bad in here anyway, I guess. Well, I don't know, maybe there is. We're gonna go to the docs. RS for us. We're going to look for specs. Specs for us. It's going to be interesting to see, like, well, I stopped streaming for a long time, so you imagine my audience has dried up, but then also my, sometimes I'm working on stuff that's really graphical, like, I could be working in Blender and on the modules that are in the game, like these modules here, and then their equivalent representation, which is in Godot. And in fact, Nish has created a bunch of these, a bunch more meshes I need to start using soon enough. And experiments. There's room in here. Test rooms. So I've got my test rooms I've been playing with here. So I've got this very graphical stuff I've been working on. And with the modules, I've got one of them has got the text string showing in this particular scene. And then section. Got my modules. So here a bunch of them have got their text string on. I just used a particular grassy HDR map for the background just to get something in the background for the lighting. Something very interesting going on with this one for its text string in this particular scene. Anyway, so this is me experimenting with my assets and how I want to arrange them and build them into parts. So this particular group of rooms was assembled in Blender out of these smaller parts. And I want to ensure that when I change these meshes, they also change over here. As I was trying for a couple of months to figure out exactly the best way to get the stuff in and manage all the links and the materials. Yeah, the background's pretty much irrelevant. In fact, the background in the game is quite funny. Like, here's the stars background. But it's actually just a stack of bitmaps that are off on one side, and then we use a grassy HDR map. And it's like, oh, camera magic. Anyway, do not look too closely behind the curtain. All the stuff will get a little bit more fancy as time goes on. Okay, so I can't give you a more in-depth demo of the game without, well, things aren't compiling and running because I'm in the middle of changing a whole bunch of stuff. So I don't really want to put my weight to one side to demo it right now. It'd be something we do like tomorrow or next time I stream. Ah, delicious. Okay. Oh, that's right. Generations. So, yeah, that's right. Grass and space. Everyone needs a bit of grass and space. So we're going to. I was wondering what's the way. There's entities res. Or is there a entity manager in the world that we should be using for it? Can we create an entity res out of nowhere? Or, yeah. It's likely that if we want to create entities for a test like this, I just need to actually just create a world. World equals specs world. No, I think we just say world new. That one comes from specs. Import from specs. I just realized that I need to make this smaller because you can't see that part of my screen. It's off the bottom. Yep. Just have a look at my OBS window, which shows me what you can see. Yes, like that. It's a little unfortunate because often I put my chat window in this region at the bottom here or something. Like, I wonder if I made this browser small enough. Put it in down here. Something like that. Seems weird to have. Make this. Yep. And, pop out there. That's what I was looking for. And the way to make that full screen. Yep. Got a little ninja in my chat window. And then I can put my chat window down here. This is what I used to do with the Twitch window too. Yeah. Let me get rid of this. Warning. Yeah. Yes, you guys are riveted to your seat. That works. Then more. Great. And then did that go away? No. Ah, so annoying. Oh well. Okay. So I was just going to create a new world. Why is this not happy? Import isworld.ext. Okay. And then with int1 equals world create entity. Oh, we probably need to say let mute world. Yep. Great. So oh, create entity dot build. Yep. Not sure why this is red. Does that make entity? Great. I need some for testing, so I can. In this case, I'm trying to. This is how we map. Mentioned there were 256 entities. This is how we map between them and the 256, between all the entities in the sector and the ones the client knows about. Mapping needs to be mute, so we can change it. So there's this glass up here, but again, a bit tricky to manage. But when we ask to see whether a particular specs entity is known, it calculates if the client knows about it or not. Run the test again. Man. So part of the reason why I stopped streaming in the first place is because it's a little bit intense. You're just trying to always keep moving, keep explaining, being exciting, etc. And wondering how people are watching and all that stuff. And so it felt like it'd be nice to relax a bit and not stream. But I've missed you guys, so I thought it'd be nice to just drop back in, take it easy, not promote too much. Normally, when I'm serious about streaming, I'll take the trouble to mention it on Twitter and so on. Get local ID for. Okay, so what was the compile issue? I missed that. Run. So here at the top, the type cannot be indexed by specs entity. Thank you very much, Travis. Yeah, I know. Constantly reminded to just chill out on stream, but you know, just thank you. Very kind. Class indices are of type use size or ranges of use size. I'm reading the text from the error, which is on my other screen, by the way. In fact, what I should do is put it here. Like this, and then you should be able to see the top of this. Anyway, here's here the slice indices are type use size. So where's the error? Okay, I think I used the wrong variable name. I was looking for the map, which is called live entity. So we should probably rename this local to int, and this one is it's either entity map or int to local, which is a map between the entities and the local ones. And then down here I use the wrong one, so I need to call this interlocal.get. It uses toLiven, but we don't want to pass in toLiven, we want to pass a reference to it, because that's how maps work. Yes, Nesh. You're going to find that I like over-engineering very much. That's probably why I'm not getting anything done. There's a lot of import errors that are no longer that need to be cleaned up. I'm trying not to think too much. It's like a performance thing of getting too tied up on what I shouldn't be working on. I'm just trying to make some progress, even if I work on things that aren't too important. It makes me happy. So, but there is a danger that I'm working on things that are less important than some gameplay thing, just because I'm scared of doing the gameplay thing. Cannot apply unary operator. Cannot apply unary operator to type this, which implies that there's no function called assert, which is odd. I thought Rust had assert. Grab the docs and just find yeah, that's how you use it. So what have I missed? Yeah, that makes this this is self.live.set this. Oh, that doesn't return anything. Set that. I think it's has. This is just I was thinking this set is the one that turns on a bit, and I should be meant to be referring to has, which is the one that tells me if a bit is set already. I'm just checking that we already have entity as live. It's on this map. Run. So the reason why this is so heavily unit tested, by the way, Nesh, is because this is kind of foundational data structure stuff to do with the networking. If this stuff doesn't work correctly, I won't even realize there's a bug until I get other really weird errors that are much harder to understand and much harder to recreate. And so I'd rather have really clear unit tests that test this particular data structure than the bugs to show up as weird effects later on, like where somebody doesn't see an entity until like much later on, or they're in the wrong place. So this particular part is very heavily unit tested. The other reason why is because, to be honest, the problem's too big and I'm a bit afraid of it. So I'm kind of cutting it to parts by creating modules I can use with good unit tests. And then I can break the problem down. It becomes easier to handle. Field entity. Oh, I just realized my error boxes. You can't see it. No field entity on type mute packet mapping. But I think I called this interlocal. Int equals that. No method name remove. And it's int to local. And it wants a reference to it. Yeah, it's got some packets we've missed. So int send, we can actually ask it to put them in. So tick int is act. It's going to be 0. Initialize this with 0 for every one of these. And latest live. Yeah, I think we said that nothing is live at the moment. Run. Oh, sorry if I'm shaking the screen for you all. I didn't even realize I was doing that. How much does it shake? Oh, that's good. It doesn't shake too much. Okay. Run. Oh, nice to see that the mic is dropping right down to absolute silence. It's because I got some good filters on the input. By the way, if you guys are trying to ever get mics working by yourselves, it doesn't drop to silence unless you actually set up a filter that notices that volume's below a certain level and squelches it for you. Okay, get local ID for this. What's the bug? Okay. This needs to be adds use size. Yeah. I think I'm kind of Nish. I'm kind of thinking that ultimately what I'm going to do is this kind of Frankenstein mix of different game engine approaches to things, and I've got very high standards, so it seemed more natural to just do it myself. Oh, the audio stream's current bitrate is lower than the recommended bitrate. Open widget. Okay, stream health. The audio stream's current bitrate. I'm supposed to use a bitrate of 128 kilobits per second. I wonder if it's mentioning that because I was silent for too long. And when it's silent, it's not sending any data. That's interesting. I might just ignore that message for now. But it's some messages showing up on my stream health. It's telling me this message here that I think it's when I'm silent. Anyway. Thanks for the compliment, by the way, at the multiplayer API. Tick act. Okay. Yeah, so this one's actually got a different constant I'm supposed to put there. Okay. Pages live bit map int d int cent. Okay, so we don't need that use size. And then Control F5. Oh, nice. It's it should be 1080 on my side, and it's actually a 4K monitor, so it's downscaling. So I'm glad it's looking nice. The error I was getting on the stream was to do with the audio, and I think it's because I'm using a dynamic bitrate for my stream. Like, probably can't change it. Probably can't change it without taking the stream down. Stream output. But I bet there's something about the audio bitrate. Okay. Oh, it's just saying that it should be higher than it is. Interesting. So it's saying here that the audio. I'm not going to change it right now because everything's working and I don't want to break it for you guys. But yeah, excellent. Mismatch types. It's telling me that these two types are different to live, and there's an entity local to int, so it should be sum, because we're assuming that that array contains a sum. It could contain a none. Yeah, the two maps should both match. I think that's everything. Compile. That was probably cutting out a bunch of it. Probably need to set it. Okay. Got us some errors. So simple mapping. Yeah. So what I do is I create 3 entities, 1, 2, 3, and then down here I try and get entity 2 twice. I do it once here and once here, and both times it's supposed to get the same ID. And the reason why is the first call is supposed to drop down here and create the ID, and the second call is supposed to find it in this map into local. And the reason why that didn't work is because I forgot to actually write it into interlocal here. So interlocal dot it. I'm surprised it doesn't have. I was thinking it was going to have a value and a key. think it's insert actually. So the key is to liven, and the data is an IDX like so. I'll pass the key in by value. Great. So that'll put it in that map, and then we should be able to find it. Run. So this simple mapping is inside packet mapping and network. So so this is now working. So packet mapping, simple mapping. This is now tracking fine. And my other tests to do with these are tracking fine. So what you see down here is some of the more high level tests. So this one is testing that the client and server are staying in sync. This one here is testing that you can bring clients online or leave them, and this one here is for ships staying in sync. Those are the ones that are failing. And the ones passing, which is interesting. Probably the ones that are failing are just failing because I changed the test data, because I changed the client ID from being quite a sensible little number expected. Yeah, so let's just look at the ship sinking. It was a sensible little world ID number like 40, and now it's this. Though that does seem particularly crazy. Anyway. Packet tracking. Let's just pop those into Git. Packet mapping, packet mapping. Tied to the bits. So, those are working, and I'll just push those up. So the next thing we had to worry about was in the synchronization. How did I get there? I think it was in sector. I've lost my chat window because Git's in the way. Cool. What's my graph telling me? Analytics. Things are settled down. A bunch of people tried to watch my stream and failed, and now it's all quiet. That's okay. So in sector, we have a routine. Sector's the thing that sector holds like space, if you will, and then inside it holds all the spaceships that are called production floors, like the parts where the conveyors are called production floors. And it's the part we're interested in right now is the part that populates the data we're going to send. It does a so-called populate sender call that figures out what we're going to tell all the clients. And so for each client, we send information about a particular factory. But we also have to populate. Where do we do that? Page down. I've forgotten where that happens. Oh, that's right. It wasn't in sector. Sector's the old one. It's called server sector now. We didn't go to the class. Whoops. Where did it go? Didn't actually bring us to the class. Okay. We'll go to the file then. Finally, sector server. And then down here we populate the data we're going to send. Populate sender. So this is incredibly hard-coded, and it's not really working because the amount of data I have to send is too large. Because what it does is it makes a list of all the clients, and it makes a list of all the different things we want to send all the clients, which is all the data in the world. And then we just send it all at once in this snapshot. And the thing we want to change is to make it so that it sends a subset of the entities, a subset of the clients into the snapshots at any given time. Yeah. I'm not going to worry about this clients list just yet. I'm going to worry about the snapshots, which is actually the more complicated part. So when you look at the sector tick, which is, yeah, so I might just close others. Notice how all the other tabs at the top are closed. And then sector server, close others. Yeah, so we cull based on view range. That's probably the most important thing. So when we decide that it's out of view, there's no point for it to be in this packet mapping anymore. We no longer need to treat it as live. It's like the client doesn't even need to know about the entity. But then the other question is, how long since we last told the client about this entity? Because even if entity's nearby, you only need to tell the client about it again if the client's going to make a mistake. If the client already knows where it is and where it's going, and it can predict its path, there's no reason for us to tell it about it again anytime soon, until it goes away. So, yeah. And then I've got a system which I added just recently in the server, in the tick, which does what you just suggested. So in do tick, down here, I've got a client enliven, which is a system I added recently. Why isn't it coming up? Interesting. Why? Maybe this doesn't compile or something. Anyway, for some reason my code, I keep trying to find symbols and it can't find them. But it basically goes through every single client in space and it figures out how far away it is from the current player, essentially the current client. And if it's within this max scene distance square, it tells it sets the client's flags for that particular item. Yeah. This is what's going to code up now. The way that this puts data into the clients needs to be tracked as well in sector server. Oh my god. Okay. Whoops, that's the wrong to-do list. To-do list. Iterate, delete a net state. We need to kill the local ID. So the thing we have to worry about is this thing called clients. This thing called net state. I think. State. Iterate over net state. Yeah. So in sector server, one particular way of doing this would be to sector server. So I want a function that's going to determine what entities need to be sent to a particular client, which is going to require me to iterate over all the net states, which are these things on the right hand side. Send, just say send the things. Okay. Let me just sketch out what how this is going to work. So we probably want a mutable self, mute self. We're going to need, in fact, it doesn't need self. What it really needs is the world. So it's called space, and it's a mutable world. Okay, so the next thing it's going to need to do is get the list of entities we're going to send. Update the list of live entities for this client. What a list of the entities that we are going to send. Can you tell that this stuff was a bit challenging for me? And I mean, this is trying to get my head around this particular task was, yeah, humbling, let's say. I have to just believe that if I was working on this game full time and I was doing this all day, I'd find this stuff a bit easier. But just getting all the moving pieces in place when it's this late and I'm a bit tired and I'm doing it that way every day is just hard. A list of all the entities we're going to send. And obviously send those. So update the list of live entities for this client. So we just need to iterate through net state for that. So it's very similar to client enliven. So let's just say we have an enliven data. Yeah, Travis. Yeah, I think so. I think so. And to not do it in a trivial way. And to track the data and to manage the edge cases. And I'm just assuming that it's going to get easier once I've done some of the concrete stuff. Like if I can create a botched, low performance, half working version, I have to imagine that I can just fix all the problems and get it faster and faster and better and better. And so I just need to keep moving forward. Update the list of live entities for the client. So we need to have one of these enliven data things on the right hand side. This is what tracks all the net states. Client list contains those data structures we were testing a bit earlier on. Enliven data. We want a enliven data, which is a states equals new clients. Need to import this. Import from prelude, and then so this is just importing from over here, and then we're using this cool unpacking feature that Rust has. We can get this from the world, so space dot system data. Yeah. So that gives us access to our states and clients, which we're currently not using. Wonderful. And we need to build a list of the entities we're going to send. So we could make a list straight up. We could make an iterator over the list. I'm glad you guys have such a high degree of faith in me. Thank you, Nish. Okay, so let's just go over all the clients that we want to. So for each entity that we want to send, we have this thing called net state, and inside net state we have this thing called clients. So the first thing we need to know is our client ID. So client ID, which is going to be a client ID, which is a U8. And we want to go through every one of these net states. So for net state in states for mute net state in states dot I think we just use join. Yeah, we want all of them. There's no other restrictions or stuff we want. So we need this thing called join. So we need a reference, a mutable reference to this. And dot join. This is how specs works. This is how it's all specs API stuff, and my god, it took me so long to get my head around this stuff. Net state. So if the net state dot clients dot has, so that tells me that a particular flag is set over here saying that this specific client cares. So has client ID dot 0. If it's true that it's in there. Okay, it just occurred to me that I can keep a bitmap of all the ones that we've looked at, which solves the problem I've been thinking about, and I haven't shared with you. Still live equals I want to track which entities the client has been told about, but that we don't want to tell them this time. And so all the entities that the client's been told about that we no longer want to tell them about are going to be in this packet mapping here. Let me just keep typing and it'll make more sense. So there's still live. Yeah. I'll just keep moving forward and it'll make more sense. So I was just thinking about whether I wanted to, there's kind of two versions of an entity going away. There's one version where the entity's gone, like poof, and there's one version where the entity still exists on the server, but we've decided that it's gone outside that range as mentioned by Travis. So we want to tell, we no longer want to tell the client about them, so it's no longer live from the point of view of that specific client. So do we worry about tracking whether it's live? And here it's going to track, it's going to know which ones are both not live and no longer present in a second. So if this particular entity is out of range, that's what this dot clients basically means, is we're not going to tell this client about it. Then we're going to continue, we're not going to bother with them. So it's like a filter. So here is an entity that we are going to tell the client about. And so the first thing to do is to get its ID. And that's what this packet mapping comes in. So we had this, in packet mapping, we had a routine here called get local ID for, right? So let local ID equal. And there's kind of two options for the local ID. Either we're going to get one, or it's going to come back with none because there was no more space to manage more local IDs. And if it runs out of space for local IDs, that means that we can't. It's like if there's lots and lots and lots of ships really close to you, you just can't manage that. I'm not going to tell you about all of them. We're going to eventually just say, no, we need to reduce the amount of area you can see so that you can manage all the stuff that is close to you. let local ID equal. So that was going to be, yes, so we need to get the specific client out of this client's dictionary I got at the start. So let client equal clients. So we're going to get mute, and we're going to use get mute. This client list as client sync. I think client sync is the thing I care about. Dot sync. We need a client sync. So we want a client sync, which is going to write it here, a reference, a mutable reference to a client sync. And so we're going to go dot sync dot get mute. And we have to pass in a key, which is going to be this client ID. And why is it not happy? Oh, because it might not have found the client. If it doesn't find the client, we wanted to just quit. We don't have a way to send that back. I think in this case we can just, if it doesn't exist in sync, we'll just create it. So it's not really get mute we want. It's insert default. There's an insert default or similar class in Rust that you can put on a dictionary. Hash map. Yeah, and there's something default. Oh, that's right. We use entry. We use the entry API, and then there's a for the entry. Then from there we use or insert. Or insert default or default. Great. Okay. So client sync dot entry that or default like so, and then here does the key need to be no longer as a reference. Now we need to copy the key in. That's fine. So if there isn't this record called client sync that tracks everything, we're going to create one. So the local ID we get use client sync. So let me just flip client sync on this side. I had it open here as in client. So we got the client sync, which is just here, and we want this thing called map. So the local ID is client sync dot map dot. Interesting how I can't figure out the symbol information and show it here, but it's a packet mapping, and then I can call this function. I keep mentioning get local ID 4. Get local ID 4 and pass in the entity we're talking about. I just realized that this join does actually need entities res in it. So we want that. Which means we need read information on entities res. So I need to put it in this. So or is it directly inside space? Let's use space.entities. Probably can. Yeah, that returns entities res, which is the thing I wanted. So if I iterate over those, I don't just get a net state from specs, I'm also going to get this thing called an entity, which tracks which one of the things I want. So everything in specs has like an ID number, which is called an entity. Oh my god, this stuff is complicated to explain. Okay, so This mute doesn't go here, it goes next to net state. Great. So we use this entity here, is used like as a key for everything. It's like a number that represents, that holds together all the parts of stuff in space. So we're going to pop it in here as the key for this, and it pops out with a new key that we're going to send the client. It's local ID. But it's possible that local ID is not going to be a real ID. It's possible, if you look in here, get local ID for, that we won't be able to get one. So if some IDX is equal to that, we can get an index, we return it, but unwrap it. Else, we're going to continue, which is a way of saying we're going to go run this loop again. We're not going to bother sending have any more. Don't have any more available local IDs for this entity. And so we're going to continue, which means we're going to drop out of the loop and go back to the top and try the next entity to see if we can do that one. So if we have a local ID, the next question is going to be, do we actually need to send it? Do we need to send this in? We need to send this information. Okay, so Travis Swift asks, so the server has the authoritative primary keys for every entity, but each client has their own local key. Exactly. So the authoritative keys are two 32-bit numbers, so 64 bits of data. And I'm just saying I'm going to turn those into a much smaller key, only 8 bits of data, and limit the number of entities we're going to tell the client about at a time to 256. Now that might not sound like a lot, but bear in mind that I treat an entire spaceship as one entity, and then we track the internals of the spaceship elsewhere. This is only for the action part of the Recall Singularity, which manages entire spaceships or players as like one big chunk. So there's not that many chunks on the screen at a given time. Just thinking about guns that spew out bullets. There'll be a lot of those around, but we need a different way of tracking those. Okay. As opposed to fully fledged entities, which is what they are right now. Do we need to send this information? Consult. We last send it. Okay, so in the client sync information, there's this thing called packet tracking. And that's tracking all the messages as they get sent. And one thing we want to know is this thing called tick int act, which is what have we told everybody about the entities so far? Yeah. Got this tick int act. I wonder if we just put. It was nice to see you, Nish. I should probably stop the stream myself soon enough anyway. Yeah. It was nice you dropped in. Thanks for dropping by, Nish, and I hope to see you again later. Catch you on the server. Have a nice day. When was a particular entity at? I mean, it's just going to be hub. Let's take int act array. We'll rename this to array. R, like a pirate. And we'll just ask for when one particular tick was act. The local ID, and it's just going to return a U32, which was the tick and which was act. So this is tracking when a particular entity was noticed, and it returns self.tick act. and the number local ID. So do we need to send this? When do we last send it? Last act. So that's how many ticks ago this particular entity was act. Take the act to get from client. Fine, let's find that mapping dot track dot. And so we know how long it's been since the client had it. We probably need to know what tick ID we're currently at. To the U32, and then there's a question down here. With last act. So like if last act is not equal to 0, then remote client knows about this entity as it's changed enough since we last sent it. And then we have to justify whether it's worth sending again here. And then the other option is else if, and we need to say client think.track. And the question I want to ask myself here is, did we just send the entity and it hasn't had time? Like was sent since, and then we put in here some time, like tick ID -5. We have some rule that we can't keep transmitting information about the same entity every single frame, even though it hasn't been act. And you might have some rules about how often, how far back do you look. Let's say we put this inside a block of code, and we move this inside. And then the question is, or even it could be last sent. Yeah. Since since I like better. Was since. And so then the distance back. How far back do we look? Depends on the entity, depends on how much it's moved, how much it's changed. So, it could be 5 for some things, but it could be less for the player's current ship that you're flying. You wouldn't mind sending that every tick, just to give the player good feedback. And then we can say still live dot set. Still live dot set this index local ID. So we're tracking which particular IDs are in use, and then down here for dead ID, and we use this thing called client sync mapping. It knows which entities were live before. Tracking and packet mapping. This one here. I feel like I've gotten a bit of a roll. This is why I'm just trying to keep going, even though I'm feeling a bit tired. So every ID that's currently live, and it's not in this map we just created called still live. Need to remove these entities from the mapping. And so the way we do that is we go to find link.map. And we set this function. There's a function down here called ensure dead. Ensure all dead. We pass in here to kill local to kill, and we want to pass in a bitmap. These are all the things we're going to remove. And then what we do is we say for the in local to kill, that iterates through the bitmap. For every one of those entities, we're going to remove it from self.entity.local.remove. Remove this entity. Oh, we can't find it. So first we have to find it. It has to be in local to kill and self.live. And then remove self.local to ent using for local ID in this. We need to find that particular entity as usize dot map. Oh, if it's entity equal to this, we're going to remove it from the map. Nice. And once we've done that, we can then do all this in one go. So we're going to clear live as and equal with not this awaken very similar to live. Unset all those bits. And for zombie, we're going to set all those bits, or those are all zombies now. So we'll put a little statement in here to just quickly quit if necessary. If self.live to kill. Yeah. If not local to kill. If self.live and not local to kill, there's not a single live thing that needs to be killed. When you combine those two things together, you get nothing. So, empty for you. turn. I'm going to need some tests to make sure this routine works the way I think it does, because it's quite complicated. Okay. Client-sync.map.ensure all dead. This, even if it's not in still live. That will clear the map of all the stuff we no longer need to track. Right. So up here we need to, we like are adding to a list of things that we want to send. We could have some upper limit. We could have some way of sorting. Yeah, but I think at this point, so right here the things we want to send that in a sorted array. Not quite sure. I am going to call that a night and sign off around now. So it was a real pleasure to have you guys drop by and watch. And if you've been watching the stream online, hopefully you can find some stuff in the channel you like. And I'd like to suggest that you drop by our Discord if you so desire. If you just search for the Recall Singularity online, you'll find the Twitter and so on. I'm sure you can figure it out. And it was really nice to have you along. Thank you for dropping by, and I'll end now. Good night.